Hello dear students, today we are discussing about evaluation of semi-solid. So in which the evaluation of semi-solid, the content are physical appearance, texture, pH, content uniformity, drug content, viscosity, spreadability, extrudability, skin irritation, in vitro diffusion, in vivo absorption, and microbial screening. So the first is physical appearance. The main characteristics need to be checked in a physical appearance are a cracking in case of cream means a separation of oil and water. Then a chance of development of granular or lumpy appearance due to changes in a parameters like temperature, or maybe the chance of change in a viscosity due to temperature, or found some crystal growth due to a fluctuation in temperature, and microbial contamination due to the less efficacy of your preservative. Also the deterioration of your product may change a color or odor because it consisting of a natural semi-solid basis. So there is a chance or marked changes in odor and color. It comes under your physical appearance, and that will be carried out by a visual appearance, or we can visually inspect this physical appearance. Next is a texture. The texture, it is tested or evaluated for their smoothness, homogeneity, and absence of grittiness, and that can be done by the rubbing of that product between your two fingers. So it is very easy to find out their smoothness and homogeneity. Next parameter is a pH. So the determination of the pH is essential, and it gives us an idea about the stability of your formulation and absorption. What is meant by stability of your formulation? Means that if your formulation pH is uh, uh, as per our decided pH, then its stability is good, and your pH is necessity because your skin pH is 5 to 6, so your pH of your formulation should be ranges between 5 to 6. So because this is useful for the absorption of your semi-solid formulation. Again, how we can check? We have to check by using a digital pH meter, or by immerging your uh, pH paper in that. So the measurement we have to done in a triplicate, and then we have to take an average and calculate a final pH of a formulation. Okay. Next evaluation parameter is a content uniformity. So your content uniformity, how we have to carry it out? We have to compare the weight or volume of the product filled into the container. What I can say that like as in weight variation. So it is your bulk formulation container in which there is a chance of a variation in a content. How it helps to assign content uniformity of your product. So this contain not more than 150 gram or ml, and that should be performed in two steps. What are the two steps? One is the label which is on that container. You have to remove that label from a container, and then you have to wash, and after washing you have to dry a surface, and weight that is called W1 is recorded, right? Then the entire product from each container is removed. First of all, you have to remove only label, wash external surface, dry that surface, and take a weight. That is called the total weight, that is W1. Then you have to remove entire product from your container and clean that container, dry it, and then we have to weight a empty container, that is called WT. So what is that weight of the product is that, or is equal to weight of your total weight is W1 minus empty container weight, that W2 is equal to weight of your product. So the average net content of 10 containers, it is not less than your labeled amount. What is mean by labeled amount? Labeled amount means which is indicated over the label of your product. Okay. Next is a drug content, means actual API which is present in your dosage form. So it is determined to check the exact amount of a drug present in your formulation, and that should be determined by using and suitable analytical or spectrophotometric methods, and it shall be fall within a specified limit as per the reference standards. Okay. Then next one is the viscosity. What is the need to check a viscosity? Because the formulation can be easily removed from the container, and easily applied to the skin. So it should not watery or not too hard viscosity, because it is easy to remove from the container and easy to apply to your skin, right, externally to the skin. And the viscosity is can be done by using a multiple viscometer like cone and plate and cup and bob, or like a Brookfield viscometer. We will discuss that what is the role of that multiple viscometer on later on side. Then next one is the spreadability. So in case of spreadability, it should possess a good spreadability characteristics, because it expresses the extent of area on which the formulation readily spreads on application to skin or affected part. So we can say that the extent of area on which your formulation is readily spread on application to skin or your affected area. So it will help, that spreadability will help to how much area will be covered by spreading your formulation. So the therapeutic efficacy also depends on your spreading value. If the spreading value is less, means it takes less time. So we can say that it having a good spreadability. So the time is taken in a seconds by two slide to slip off from formulation under the direction of certain load. Means there is an assembly in which a wooden frame will be there, and on that wooden frame one your slide is fixed and another slide which is moved over that fixed slide. So what we have to do, we have to apply a load for that moved slide, and we have to apply the formulation on fixed slide, and just place that moving slide over the fixed slide, and those are having a pulley at the one end of that wooden frame. So you have to that the threads which is over that pulley, and those which are having a load which is applied to that, and then we have to just place that moving slide over the fixed slide, so that we have to record time taken to slip off from that fixed slide. That is called a spreading value or spreadability time. So lesser the time taken for a separation of two slides, better will be the spreadability. Okay. Then extrudability is a formulation filled into generally in a collapsible tube in case of a semi-solid. So it is the weight in grams required to extrude 0.5 centimeter ribbon of formulation in a 10 seconds. Means when we apply the force with the help of a finger, it should be removed. It should be extruded 0.5 centimeter by applying the pressure with the help of that thumb within the 10 seconds. That should having a good spreadability. An extrusion rheometer extrudes sample through the orifice under pressure and is in a tiered container. Next one is the skin irritation test, or which is also we can call it as a safety test, and that should be based on the base which is used in a formulation may cause irritation or allergic reaction. Hence this test we have to carry out for evaluation of your semi-solid, and that is a non-irritancy evaluated by a patch test. So that they address skin test is that the animals like rabbit and guinea pig are used for the test, and here is showed from back of your animal on both sides. One slide is acting as a control, another side is acting as a test formulation. So the site which is observed for a sensitive reactions, there may be a results obtained in grade and the symptoms like erythema or a edema. So we have to carry out that semi-solid for ophthalmic ointment also. And erythema means the redness like skin, and edema is the swelling or this fluctuation of your eyes. So the test is carried out in end of 72 hours, and two reading we have to carry out, and that irritation test is carried out for 21 days for this semi-solid preparation. Right. Next test is in vitro diffusion and in vivo absorption. So for in vitro evaluation of penetration, we have to use this France diffusion cell apparatus that having such kinds of construction, and the condition like skin, generally we are using rat abdominal, rabbit or protein human cadaver skin. The temperature condition is 32 degree plus or minus 1 degree Celsius, and media which is used in this chamber, that is simulated fluid, and that is a pH having 6.8 pH of that media. So this construction of that assembly is consisting of a donor chamber in which there is an donor compound we have to place. Then membrane will be there, that is we can call skin of your animal, and then this is the receptor chamber and that receptor chamber having an facilities like sampling port will be there, sampling chamber will be there, right? Then heater will be there for maintaining the temperature, water jacket is there to maintain your temperature, and stirrer will be there. So we have to assemble that assembly, place your formulation here. This is your skin, right? Maybe a rat abdominal, rabbit or broken human cadaver. You have to place that or assemble that assembly. Then after some time, there is an absorption or diffusion will be takes place. That is we can call a passive diffusion, right? So after some interval of time, you have to take that sample and evaluate it for spectrophotometrically. Likewise, it gives us an idea about the amount of drug which is diffuses from that skin, that is called transepidermal absorption into the systemic circulation. Next evaluation parameter is microbial screening. That microorganism can grow if no preservative is added, or if or even if added, its efficacy is reduced due to interaction with other ingredients. So the microorganism may get into the preparation during handling after. This is one of the chance. Therefore, aseptic techniques of handling are needed, and we have to carry out the screening of Staphylococcus aureus, Pseudomonas aeruginosa, and E. coli. Right? Why? One of the question is asked in why single point viscometer is not useful in a semi-solid, because the flow of semi-solid does not follow a Newtonian relationship, because the graph shearing stress versus when we can plot shearing stress versus a rate of shear, it is not a straight. So we can say that the semi-solid preparation having non-Newtonian flow, either plastic or pseudoplastic flow. So the thixotropy may arise from breakdown and build-up of a floccles. Okay, all of you know that thixotropy. The viscosity of your semi-solid is equal to shearing stress by a rate of shear. So it having an if the Newtonian system will be there, we can found a straight line. But in case of semi-solid, there is a non-Newtonian flow. So this is an exponential graph we can observe, right? So it is not a straight line graph, which means viscosity of system will not remain constant but vary depending on change on your shear stress. So your viscosity will be depends on what? Shear stress, right? So a single point viscometer can provide only a one shearing stress. So this means it provide only one point on a rheogram, which is of no use in case of non-Newtonian system. Hence, we require a multiple viscometer. Therefore, in order to study the rheology of your semi-solid, multiple viscometer that can provide variable shearing stress value may be used, like cup and bob and cone and plate. So the important thing is for the rheology is that the spreading property we have to evaluate according to rheology and adherence to the screen. How much spreading value is there or spreading property will be there, and how much time it should be adhered. It means for their desired effect it should be adhered to the skin, because of there is a release of your drug from the vehicle to the skin epidermis and epidermis to the systemic circulation. Then there is a removal, or it is the rheology is important because the removal of the formulation from the containers or the jars and extrusion from the tubes. Okay, then capacity to take up a solids means how much amount of drug it should be, we have to incorporate into your semi-solid bases, and the release of drug from a base means how the release is takes place from the vehicle to the epidermis, and then it transferred to the systemic circulation. Okay, so this all are comes under the evaluation of semi-solid. Thank you.